AC generator. A generator or dynamo is a device which converts mechanical energy into electrical energy. A generator is a device which converts mechanical energy into electrical energy. You might
So
have,
which page?
sorry, page number 38.
Explain. Okay.
Page number 38. So, a generator or dynamo is a device which converts mechanical energy into electrical energy. You might have seen some generators. So, generators are those devices which converts mechanical energy into electrical energy. An AC generator is the one which produces a current that alternates or changes its direction regularly after a fixed interval of time. That is, it is a device which converts mechanical energy into alternating form of electrical energy. So an AC generator is the one. So AC generator is the one which produces alternating current which changes its direction regularly on a fixed interval. Now, principle. The working of an AC generator is based on the principle of electromagnetic induction. Just like transformer, AC generator also works on the principle of electromagnetic induction. When a closed coil is rotated in a uniform magnetic field, when a closed coil means like this is a coil, this is a closed coil. This is a closed coil. When a closed coil is rotated in a uniform magnetic field with its axis perpendicular to the magnetic field, the magnetic flux linked with the coil changes and an induced EMF and hence a current is set up in it. So I am drawing the diagram of AC generator and let's understand how does it works. So these are two these are two poles. These are two poles of a magnet, and preferably a single magnet. And this is a horseshoe type magnet, means it is curved from inside, from this side, and from this side also it is curved. So actually, I have made this zigzag line here and a zigzag line here just because This is the poles. This is the north pole and south pole of the same magnet. So this magnet takes a turn like this. It is a big magnet and it takes a turn like this. So I am just showing the north end and south end of this magnet. Okay. Now we are going to put a coil in the coil between these two poles of this magnet. Okay, so these two are the poles, and now I'm going to put a coil between a rectangular coil. So one by one, we will understand the construction and working of this AC generator. S1, S2. B1, B2. B1 and B2 are brushes. This is load resistance, LOAD, load. R is the resistance of this load, and axis of rotation, axis of rotation, P, Q, R, S. Motion is like this, and this is this PQ and this RS. This is called armature. Armature. So this is how an AC generator looks from inside. Now, construction. It essentially consists of the following main parts. Now, I am on page number 39 of the notes. It essentially consists of the following main parts. First is field magnet. It is a permanent magnet of the horseshoe shape in a small dynamo or magneto, or it is a powerful electromagnet in a large dynamo. So, first of all, we have a field magnet. So N and S, these north poles and south pole, this north pole and south pole, they both are essentially of a same strong magnet, and that magnet is called field magnet. The second thing is armature. Armature is this one, PQRS. This is a coil. So armature, it consists of a rectangular coil PQRS having a large number of turns of insulated copper wire wound on a soft iron cylindrical core. So this PQRS is a coil, and we are just showing one turn of the coil. PQRS is one turn of the coil. It consists of huge number of turns. There can be 50 turns, 100 turns, or even 1000 turns. It depends. It depends on the it depends on the type of generator, that how big generator you are actually constructing. So second one is armature. Third is slip rings. Slip rings. This one is ring. This ring is just like bangles which we wear in our hands. So slip rings is S1. First is S1 and second is S2. So how it is constructed? Look, this PQRS is a rectangular coil, and we have to construct a closed coil. We have to construct a closed coil. So look, this P side is connected to this slip ring S2, and it is going from inside S1, but it is not touching S1. And this S is connected to slip ring S1. This is connected to S1. S side is connected to S1 and P side is connected to S2. Now S1 and S2, S1 is connected to B1. B1 is carbon brush. B1 is carbon brush, and B2 is again a carbon brush. It is preferably it is made up of graphite. So B1 and B2, because they both are good conductors of electricity. So now how does it works? Fourth is brushes. Two graphite or flexible metallic rods called brushes are lightly pressed against the two slip rings. Lightly pressed means they are just touching. Whenever generator works, it creates a humming sound like this. Why? Because these slip rings are touching these carbon brushes, and these are made of graphite. Graphite is a very soft non-metal. It is a very soft form of carbon. So graphite does not create a huge noise. If suppose if we have these slip rings of copper, and if these brushes are also of copper, then when we rub copper against copper, then how bad sound it creates. So that's why, just to reduce the sound in a generator, these carbon brushes are used, because they produce soft sound. Now the brushes B1 and B2 remain fixed in their positions and maintain sliding contacts with the rotatable slip rings S1 and S2 respectively. So brushes B1 and B2, they maintain a sliding contact with these two slip rings S1 and S2. Fifth is source of energy. The armature of coil is rotated about its axis with the help of a turbine or any other device connected to it. Source of energy. Actually, what we are doing here, actually we are simply rotating this coil, and the concept of AC generator depends on this only. The concept of AC generator depends on this only. When we rotate a coil, it produces an electric current. It produces an electric current. And how it produces? Whenever whenever force is applied, three things we have done, we have studied Fleming's left hand rule. Whenever current is applied, whenever we have current is represented by this central finger, magnetic field is represented by this index finger, and force is represented by our thumb. So whenever we provide force and we wish to obtain electric current from the force, then Fleming's right hand rule is not used. Then we use Fleming's left hand rule is not used. We use Fleming's right hand rule. Fleming's right hand rule is also just like Fleming's left hand rule, but there is only one difference. The difference is this: this is the thumb represents force, the index finger represents magnetic field, as in Fleming's left hand rule. Now, what this central finger indicates? This time, central finger is indicating induced current. Induced current, the current which gets produced by the motion of this rectangular coil. And how? Just see the working. Try to understand the working. So first of all, this is axis of rotation, and with the help of diesel engine, with the help of any other engine, we are able to rotate this coil. We are able to rotate this coil with the help of any external engine. Okay, so we are rotating it like this. So first of all, this PQ is experiencing a force in the upward direction. This PQ is experiencing a force in the upward direction. Magnetic field is fixed. Magnetic field is always from the north pole. Magnetic field is always from the north pole to south pole. So if we look at this one, at this PQ, if we look at this PQ branch, then direction of forces, thumb is upward, because it is experiencing a force in the upward direction. So thumb is in upward direction, and this index finger is in rightward direction. Then where is our central finger? Central finger is into the page, and our purpose of keeping it in this slanting way, keeping it in a slanting way, is that actually in real this coil is fixed into the midway of north and south pole like this. These are also placed in slanting way. It means that north pole is fit like this and south pole is fit like this. So this is not placed like this. Actually, this rectangular coil is placed like this. So thumb means force. Force is in the upward direction. Magnetic field is in north to south direction. Then central finger is into the page. It means that current is flowing into the page. Current is going from P to Q. Current is going from P to Q. So this is the direction of current which we see. Is this clear to you? Anusha, is this clear to you?
Yes, sir.
Okay. Wait. Can you please wait for 2 minutes? Can you please wait for 2 minutes?
Yes, sir.
Okay, I'm back. So now, uh, when we apply force like this, then our thumb will be in the upward direction. Thumb indicates the direction of force, and this index finger indicates the direction of magnetic field, and central finger is into the page. It means that current is going from P to Q. And at the same time, when this PQ is moving upward, then at that time this RS will be moving downwards. So what will be the direction of force in this RS? Direction of force will be downwards. Okay. So if we apply this Fleming's right hand rule in this section RS, if we apply Fleming's right hand rule in the RS part of this coil, then force will be in the downward direction. Magnetic field will be in the upward direction. Then central finger will be in the front direction. It is coming out of the page. So it means that current is coming like this. Current is coming like this. Now we have to check that whether this current is completing its path, whether this current is completing a loop. We have to check that. So loop means this current is going from P to Q, then from Q to R. It's a way the current moves. So current will move from P to Q, then Q to R, then from R to S, and after that it will go to brush B1. It will go to slip ring S1, and slip ring S1 is connected to brush B1. Then current will go like this. This current will go like this, and then current will go to this load. What is load? Load is load is any tube light, load is any TV, any fridge, fan, AC, anything, any electronic equipment. It is connected here as load. So current will go in this load, and this load will start working because now it is getting current. Okay, now this current always completes its path, always complete loop. Then current will go like this, like this, like this. Then it will go to brush B2. Brush B2 is connected to S2, and S2 is connected to P. So in this way, this current is completing its loop. Now this is one part. Now secondly, what we can see. So firstly, current is moving like this. Secondly, I am removing all this. Now, what will happen? This PQ after a half cycle, this PQ will come here. PQ will come here. You have to assume it because I'm not going to change this diagram. This PQ will come here. Okay, or okay, just imagine it. This PQ will come here, and SR will come here. Now, what SR will experience? So SR is connected to this B1. So what SR will experience? SR will experience an upward force. This in the next half cycle, this SR is going to experience an upward force. If you say, you can write again also. It is not getting selected. Okay. I'm drawing a diagram here like this so that you can understand it, what's actually happening. This SR will come here, and accordingly B1 will also move like this. SR So after half cycle, this SR will come here, SR, and this PQ will come here, PQ. And now think what will happen. What will happen now in this SR? After half cycle, what will happen to this SR? SR will experience an upward force. An upward force, because we are rotating it like this continuously. We are rotating it like this. SR will experience an upward force, and magnetic field is in this direction. So SR is experiencing a force. SR is experiencing a force upward, and magnetic field is in this direction. Then central finger is into the page. It means that this time SR is experiencing the current I is into the page. Earlier the current I through SR was out of the page. Force was in this direction, and in this case force was in downward direction. So now SR is here. So SR is experiencing a current in this direction, and PQ will experience current like this in this direction. So what will happen now? This time current is going to B2. Look, this current I is going to slip ring 2, and slip ring 2 is connected to B2. So it is going to this, and then current is coming like this, and it is connected to B2. The current will go like this, and it will complete its path like this, and this one B1 is connected to S1, and S1 is connected to this. So in this way, current is completing its path. So what I have seen here, that during the first half cycle, the current was flowing from B1 to B2, and in the second half cycle, current will flow from B2 to B1. So what is this? This is alternating current. Alternating current changes its direction after every half cycle. So is the working clear to you? Is this clear? Anusha, are you there? Is the working of this AC generator is clear to you?
Please explain like the last part again.
Last part, this one.
Yeah.
Okay.
Just that.
Okay. This PQ, actually we are providing a rotational torque. We are providing a torque like this. So this PQ after half cycle, if you consider this to be a coil, and this coil is placed like this. So if we are providing a force like this here and a force like this here, then what will happen? This is side PQ. So after half cycle, this PQ will come here, and this RS will come here, and after another half cycle, this PQ will again come here, and RS will again come here. So I am just telling you that after half cycle, what is going to happen after half cycle. So for the first half cycle, this PQ is experiencing force like this, and current is from P to Q, and in RS, current is from R to S. And after first half cycle, this SR will come here, SR came here, and this PQ will come here, PQ will come here. And since we are rotating this coil again and again like this, so now this SR is going to experience a force F in the upward direction, and magnetic field is rightward. So this time the current will move from S to R. In the first half cycle, current was moving from R to S. In the second half cycle, current is moving from S to R. And because this SR is connected to slip ring 1 and B1. So now current is going, it means that current is coming to this like this. In the same way, this PQ, earlier current was going from P to Q, and in the second half cycle, current is going from Q to P. So current is going from Q to P like this, current will go to S2. So S2 is connected to B2. So now current will go from B2 to B1. Earlier it was going from B1 to B2. So B1 to B2, means that it was going in, suppose that it was going in right direction, then B2 to B1, it means that now it is going to from right to left. It means that after every half cycle, current is changing its direction. And this is the basic definition of alternating current. Is that clear?
Yeah, sir.
Okay, now, so this was all about its working, and working was explained on this page number 39. Sorry, page number 40. Now, expression for induced EMF. This is very much simple. Expression for induced EMF. Page number 41. I am on page number 41. Let capital N number of turns in the coil. Let capital N be the number of turns in the coil. Capital A face area of each turn. Capital B magnitude of the magnetic field. Theta angle which normal to the coil makes with field B vector at any instant, and omega is angular velocity with which coil rotates. Actually, this theoretical part, this page on page number 41, which I am discussing right now, this is exactly the same which we have done in electromagnetic induction chapter, theory of AC generator. We have written the same PDF. I can show you. You can check it, theory of AC generator. It is in the last section of that electromagnetic induction chapter. So magnetic flux linked with the coil at any instant t will be, we know that what is magnetic flux. Can I move on to the next slide? Do you want to draw this? Anusha, can I move on to the next slide?
Yes.
Okay, so magnetic flux linked with the coil at any instant t will be magnetic flux linked with the coil phi is equal to NBA cos theta. NBA cos theta. And what is this theta? Theta is equal to omega t. We know that. Phi is equal to NBA cos omega t. NBA cos omega t. Since E is equal to minus d phi by dt is equal to minus d by dt of NBA cos omega t. So E is equal to minus sign is there. NBA is constant. Why? N, what is N? N is the total number of turns in the coil. Capital B is magnetic field. As long as magnet remains the same, magnetic field will also be the same. Capital A is area of the coil. So area of coil is also will also be the same. And what will be the differentiation of this cos omega t? Differential of cos omega t is minus sin omega t. It is minus sin omega t, and we will differentiate this omega t with respect to t again. So it will be omega. Okay, and minus minus is going to be plus. So E is equal to N B A omega sin omega t. NBA omega sin omega t. And we know that we did it earlier in the last chapter that NBA omega is E naught. So E is equal to E naught sin omega t. E is equal to E naught sin omega t. So what we are getting here? We are getting EMF. And EMF, if we get EMF, then simply current can be generated. So this is how an AC generator works. Now, the next point is hydroelectric power station. So this is again a theoretical concept, theoretical topic, hydroelectric power station, where water is used to move the turbines, and those moving turbines create electricity. So in a hydroelectric power station, water is stored in a dam at a height from where it falls into a giant water wheels or turbines. These turbines are connected to the loops of wires in AC generators, and this is how current is generated. Thermal power station. In thermal power station, electricity is generated by burning coal. So in a thermal power station, steam is produced by boiling water using coal or oil as fuel. The turbines coupled to the loops of AC generators are rotated by steam, and thus electrical energy is generated. Nuclear power plant. In a nuclear power plant, a nuclear fuel is used instead of coal to generate electrical energy. Now, I have given three questions here. So, question number one. Ravi pedals a stationary bicycle, the pedals of which are attached to a 100 turn coil of area 0.1 meter square. Ravi pedals a stationary bicycle, the pedals of which are attached to a 100 turn coil, So, the total number of turns in the coil, capital N, is 100. Capital N is 100 of area 0.1 meter square. Area is 0.1 meter square. The coil rotates at half a revolution per second, and it is placed. The coil rotates at half a revolution per second. Revolution per second. Revolution per second means frequency. Understand? Revolution per second means frequency. Half a revolution per second. Per second means hertz. So F is 1 upon 2 hertz. 1 upon 2 hertz. Half a revolution per second. Revolution per second means hertz. So frequency is half hertz, and it is placed in a uniform magnetic field of 0.01 Tesla. Magnetic field B is 0.01 Tesla, perpendicular to the axis of rotation of the coil. Perpendicular to the axis of rotation of the coil, it means that theta, perpendicular to the axis of rotation of coil, magnetic field is like this, and axis of rotation is like this. Okay, perpendicular to the axis of rotation. Always magnetic field is perpendicular to the axis of rotation. It is not along the axis of rotation. So this is just to confuse us. What is the maximum voltage generated in the coil? What is the maximum voltage generated in the coil? Maximum voltage is this one, E naught. E naught is peak value. And what is this equal to? This is NBA omega. We have N, we have B, we have A. Omega can be calculated. We know that omega is equal to 2 pi f. Omega is equal to 2 pi f. So omega is equal to 2 into 3.14 into, what is this f? This is 1 upon 2. So 2 will cancel out this 2. So omega is equal to 3.14 radian per second. The unit of omega is radian per second. Now E naught is equal to NBA omega. What is N? It is 100. What is B? It is 0.01. What is A? It is 0.1. And what is omega? It is 3.14. So decimal goes away. 100 will come here. 100. So this is 0.314 volts. Is that clear to you?
Yes.
Okay. In the same way, we have two more questions. Just try them, and if you face any problem, then tell me. I have left two questions in transformer and two questions I am leaving in this one, AC generator. And this chapter is finished. And after that, we have to start with the chapter, which one? Atoms. Atoms, na? atoms na. Okay, just wait. Just can you check your WhatsApp?
Yes, I can.
Okay, wait. I'm sending you something. I have sent you a PDF. I've sent you a PDF of last 4 chapters. Have you received it? Just check.
Yeah, yeah.
Okay. So last 4 chapters are there. Dual nature of radiation and matter, atoms, nuclei, and semiconductor electronics. So all the 4 chapters are there in these notes. So dual nature, you told me that dual nature you have done. है ना? Chapter 11, dual nature of radiation and matter. We have to start next with atoms. These are very small chapters. These 4 chapters are very small. You decide and tell me which chapter. Just drop me a message on WhatsApp only, and then we will do. We will start that chapter. Atoms or nuclei or semiconductor, anyone, whichever you want. Electromagnetic waves is again a very small chapter. You can do it by your own. And tomorrow we will be having an off day. Or is there any chance of taking class tomorrow?
No, I'm fully booked. Chem and math.
Okay.
Friday, I'm a little bit more free, but I'm not sure because I might be going out because
Okay.
in the evening for dinner because
Okay.
celebrating my birthday. But yeah,
Celebrating what?
my birthday.
Your birthday?
Yeah,
Day after tomorrow?
yeah. No, it was on Monday, but I don't want to go out, so we'll go out during the weekend.
Okay. So your birthday is basically on Monday,
Yeah, it was on
17th, na?
10th. No, this Monday it's done.
Okay, your birthday has gone on this Monday and you have not celebrated it.
No,
Okay.
okay.
Just tell me, day. You can tell me tomorrow or day after tomorrow that whether
Yeah.
we should plan a class or not. And
But I am coming home from school early, on Friday. I come home by 12:30. So by the time I finish school, it will be 1:30.
okay, I am telling you one thing. Just note, 3:30 p.m. to 9:30 p.m. of Indian Standard Time. 3:30 p.m. to 9:30 p.m. I am occupied, and we can plan a class before 3:30 or after 9:30. You tell me, okay? And take your time.
I'll just inform my
Hi.
dad and I'll ask him.
Okay,
And I'll
okay,
inform my dad tomorrow. Yeah.
okay. No problem. Okay, Anusha. Then, yeah.
Thank you so
Okay.
much.
Bye.
Have a good day.
Bye. Good night.
Good night.